All right, now we're going to do the debugging video because code that I just wrote doesn't quite work. Um, want to see what I can do to fix it. So first thing I'm going to do is just plug in conform 0, 0 and see if it gives, yeah, it gives x is 0 and t is negative 1000 as I expected. How about 0, 0.1? Maybe, yeah, let's see what happens if I say 0, 0.1. Okay, 0, 0.1 gives us an indeterminate. Why is that? Okay, so I'm imagining some point around here, and if it was at the origin, it would give us 0, negative 1000. This point actually should be, um, it should stay exactly where it is. That's the one point that should stay exactly where it is. Yeah, as a matter of fact, this line should not be scaled at all. We're not going to scale that line. So what should we do? We're going to change this line. So instead of asking if phi comma tau equals 0 comma 0, we're just going to check whether phi is 0. If phi equals 0, comma, and we're going to send out phi comma tau. It will not change anything. Probably won't fix everything, but it might bring a few less errors. Yeah, it's got less errors. One thing to notice is obviously there's some kind of problem with the two if statements. I need this. I mean, this is definitely coming out to be a straight line. That's good news. The bad news is that we've got it. Well, actually, we've got things reversed so that on one side things are coming down one way. So this looks right on the right-hand side. We just need to fix the left-hand side. And my intuition just says, let's make that negative. That might not work. I didn't think it through. And indeed, that came out just horrible. So put that negative sign back. Gosh, it just looks like it's upside down on the left-hand side. So what if we just left everything the same, except said if C phi is, whoops, if C phi is less than 0, comma, negative 1 minus r times that plus 1, comma, and we want this whole thing again. So if it's greater, so it looked right on the one side, it looked wrong on the other. So let's just make it positive on one side and negative on the other. And really, except for fixing up the boundaries, the boundary box, we want to include more towards the bottom and some other things like that. It looks pretty reasonably good, I think. So a good range would be from, say, -2 to 1.3. -2, is that 1.3? 2, 3, 4, 5, 1, yeah, -2 to 1.3. So let's put in another one here. So we'll go with the y variable going from -2 to 1.3. I'm going to redo all of these in a little bit, basically because I want to set up a graphics grid with all 4 of these things in it. And that, yeah, that's it right there with the conformal time. Interesting. All right, so now things are going to have to change about the code because I want to have all 4 representations of the graph, all 4 mappings in place at the same time, which means, in particular, we're going to be renaming these things. This thing starts with C points. We've got eGrid, group, and C points. And what can I do with this? I can change the name of eGrid to eGrid FO for folded out. Group is going to become group folded out. C points is going to be C points folded out. Then this is going to be eGrid folded out, group folded out, C points folded out. And after scaling, it's going to be eGrid scaled, group scaled, and C points scaled. I'm going to get rid of all of those if statements because it's going to be done every time. So this is scaled, 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 and this is going to be conformal. C-O-N-F, conformal, conformal, and conformal. Then I'm just going to get rid of the if statements so that everything's done every time. We're not going to be doing different things. We're just going to have all of those. We're not even going to define show fold out, show scaling, and show conform. We're just going to change those so that they happen every time. And then we got to modify this part of the code, which is building the lines, and it's going to also be copied 3 times. No, actually 4 times. Goodness. We're going to have build the lines, build the lines, build the lines. I'm going to do build the lines 4 times. The first time is going to be completely unmodified. The second time is going to be the folded out version. So it's going to be FO, table line eGrid FO, and everything else I think stays the same. This SUMList function does not need to be redefined here. So I will delete that in all 3 contexts down below. I don't think we need it. 1, 2. How come I only had 2 of them? SUMList. And really it should probably just not appear in there at all. It should be up in the function definitions up above. C points are our functions. There's conform. Let's put that in there. SUMList. Okay, I think each of these needs to be changed twice. So Euclidean timelines folded out is constructed from the eGrid folded out. EU spacelines is also constructed from the eGrid folded out. EU spacelines folded out is constructed from the EU spacelines folded out. And the eGrid folded out, and I think that takes care of that. Hubble world lines folded out from group folded out, and nothing else. Ironic Cosmo timelines folded out is group folded out. Now come down here and do the same thing again with scaled. EU spacelines scaled, eGrid scaled, EU spacelines scaled, Hubble world lines scaled, group scaled, Cosmo timelines scaled, group scaled. And then the last one is going to be conformal, C-O-N-F, Control C, eGrid, conformal, EU spacelines conformal, eGrid conformal. EU spacelines conformal is concatenated. EU spacelines, whoops, conformal. Table eGrid conformal. Hubble world lines conformal is going to be group conformal. Ironic Cosmo lines conformal is going to be group conformal, constructed from group conformal. Then we'll have this is going to be unmodified. How come I can't click on the screen? Okay, so for the first set of graphics, I'm going to call the Euclidean map. The second graphic I'm going to call fold out map, and it's going to be constructed from group FO, I think, Hubble world lines, FO, ironic Cosmo timelines, FO, EU timelines, FO, EU spacelines, FO, E-grid, FO, C points, FO, and that's that. I am probably going to want to change the plot range here for this one. As a matter of fact, we'll see. And then I'm going to copy and paste this thing 2 more times so that we'll have 2 more graphics. Except this one is going to be called not the Euclidean map, but the scaled map. And this one's going to be called the conformal map. So I've done 2, 3, 4, 5, 6, 7, 8, 8 SCs, conformals. I have 1, 2, 3, 4, 5, 6, 7, 8. So that should be right. And then create the graphics grid. And I come down here to the bottom. And there it is. The only thing that needs to be done now is fix the scales so that they're occupying a little bit more of their space. For instance, this one should go from about 0 to maybe 1.3. And this one should also go from about 0 to 1.3. And the conformal map should go from about -2 to 1.3. All right, see how that looks. Let's make this positive 1.3. Okay, it looks pretty good. There are some issues with the scaling factor. Aspect ratio is kind of an annoying thing for the job here because it uses the golden ratio by a standard, but then it also need to adjust if you want this to be scaled with this. Well, you can either just make that scale the same, like go down to -1.7, or just maybe go automatic on those. I don't know. Anyway, this needs to go down to like -1.5 instead of where it went. Okay, there we have things with this going from -1.5 to +1.3, and this one going from -1.7 to +1.3. I guess, you know what? Well, I don't know. I'll make it -1, and then at least everything fits on the screen. It's not quite exactly -0.7. The reason I chose -0.7 was because that makes this scale and this scale the same. 1.3 minus -0.7 is 2, is what? It's 2. Interesting. Is that, yeah, I don't know if that was a good idea or not. All right, since those aren't to scale horizontal to vertical, I might as well just show the graph as big as possible in the space that I have. All right, next thing I want to do is put plot labels on them, axes labels, I think. So I can see when I put an axes label of x and t on here, it shows a teeny tiny little x there and a teeny tiny little t there. I think I'm going to need those to be bigger because, well, that sort of shows up. Maybe I'll go ahead and use that. Okay, I just want to do one more thing before I call it a day. Um, Before we do all these things, I would like to use the function LTList on all of our lists, all of our point lists. And the idea being, if I can see where I'm starting, right here, the idea being that I'm going to do a Lorentz transformation around the origin, the Big Bang origin. It's not going to be dramatic because I'm a little bit afraid of errors. Uh, well, we could make it more dramatic. Um, why? Let's see. We have, man, max rapidity of 1.5. If we made that 1.0, we could make a real dramatic one. Let's change that to 1.0, 1.0, so that we can do, because I know that it runs into errors if we make that too big. So I'm going to do Lorentz transformation of 0.5. That's approximately half the speed of light. So we're going to Lorentz transform it, everything, um, to make E grid equals LT list 0.5 on the E grid. E group, no, just group. Group, Euclidean, we got Euclidean group, grid, we've got the group equals LT list. I'm hoping this works. I'm kind of spending a lot of time on it, if not. So I'm doing a huge Lorentz shift, Lorentz boost on all of the points before we start. So that central line is no longer a Euclidean line. It's one of the Hubble observers that is in motion with respect to us. And this is kind of, I mean, I didn't know what exactly to expect, but this is pretty similar. I I was expecting this to curve some. I didn't know exactly what the final form would be, but this does seem to curve some. So there's some things I'm going to have to explain. This one is pretty much exactly as I expected. We've accelerated to the right, so these these lines from the original space are moving to the left. Speed of light is still constant, as we should expect. Then this one over here, though, the speed of light appears is still constant in this one, in the tau phi versus tau plot. I was kind of expecting these events to remain attached to here. Anyway, I think I have a bug because whatever, if 3 points are defined uh, at about the same place over here, after the transformation, those same 3 points should appear in the same place. So if this light cone begins at the intersection of this third red line down, it should also appear on the third red line down over here. Wait, third red line down and the black line between this point and this point. Where is it over here? Can't get it over there. That point should have been on the third red line down over here too. And so either that or somehow this point has become that point, which would be strange. Um, Ooh, you know what I'm seeing now? I'm seeing that this line is not meeting up with these dots, which means the error is in the foldout map associated with the points C points. C points FO. There we go. Let's see what it looks like now. That's what it looks like now. It looks much better. Let's see about getting a limit on this thing. See where I can, how far I can go and before I start getting an error. Try 0.6. That's what it looks like with 0.6. Here's what it looks like with 0.7. Here's what it looks like with 0.8. Here's what it looks like with 0.9. Here it is at 1, and you'll notice 1 was the maximum rapidity that we had in this space, so it's coming up to a straight line here, a nice perfect edge. And plugging in 1.1, it just keeps running and running and running, which kind of suggests to me that we might be hitting some serious problems with rounding, because these points are being mapped to a location really close to the really close to the singularity, and it might be having trouble with indeterminate numbers and stuff like that. Anyway, that covers it for today. Thanks for watching.